When we talk about similarity, similarity incorporates polygons that have the same shape, but they're different sizes. So when two polygons are actually the same, when they're congruent, congruent means that they're exactly the same. So if you think back to congruent triangles, if I have two triangles here and all three sides match up and all three angles match up, and I'm going to use the different arcs here. Sorry, my pen decided to poop out on me a little bit, so I have to kind of go back. There we go. And those three and those three. So those are congruent triangles because all three sides match up and all three angles. The triangles are same all the way around. Not only are they the same shape, they're the same size. When we talk about similarity, we're not talking about the same size. We're only talking about shapes, and I'm trying to erase that. It's not letting me. So let's look at similarity with shapes. As we look at shapes that are considered similar, and I'm going to show you some examples here, let's consider the most basic shape that you could probably identify as all of them being the same shape. All of these polygons are the same shape, even though they're not all the same size. The square. If I have a square, all squares are the same shape because all squares have 4 right angles and all 4 sides are the same length, which means as squares get bigger and bigger and bigger, or smaller and smaller and smaller, they're all still the same shape, every single square. So look at this example here. If you look at the small square and the big square, how do I know they're the same shape? Basically, that means we're going to talk about a common factor or a scale factor here shortly, that I did everything the same to get from this side to this side to this side, and this side to this side, and this side to this side. I basically did something uniform to make the square change size without changing shape. And if you look, how did I get from 4 to 16? I multiplied by 4. How did I get from 4 to 16? I multiplied by 4. How did I get from 4 to 16? I multiplied by 4. How did I get from 4 to 16? I multiplied by 4. So what I did was I multiplied every part of the square by the same common factor or scale factor, which in this case is 4, because 4 times 4 is how we got 16 for each one of these. Let's look at a couple of other similar figure examples here. Here we've just got some plain old quadrilaterals. And again, one component of similar figures is that their angles have to be the same. In order for things to be the same shape, the angles have to all match up. However, caution, only in triangles, which is what we're going to deal with in this unit, do congruent angles that match between the two figures ensure that they are the same shape. You can have two figures have the same angles, but not necessarily be the same shape. Think about a rectangle and a square. A rectangle that is not a square and a square are not the same shape, but they have the same angles. So while having the same angles is required, a matching set corresponding congruent angles, it doesn't necessarily guarantee that they are the same shape. So if you look here, 6 over 4. If I were to look at how did I get from 6 to 4, basically that ratio, that common ratio, 6 to 4, is 3 over 2. And I mentioned scale factor earlier. Scale factor is the actual factor you multiply by, and the ratio is the actual ratio. So there is a difference, and I will explicitly explain that. 9 to 6, 3 over 2 if I reduce it. 12 to 8, 3 over 2 if I reduce it. 15 to 10, 3 over 2. So you can see they all have the same common ratio. Look here. Look at these two polygons. 4 over 8. If I went from 4 to 8, what did I do? If I went from 1 to 2, what did I do? If I went from 5 to 10, what did I do? If I went from 6 to 12, what did I do? And you can see the common ratio. The common ratio from the first one to the second one is 1/2. All of these have the same common ratio. Another example, if you look here, I went from 5 to 10. I doubled it. I went from 2 to 4. I doubled it. I went from 3 to 6. I doubled it. I went from 1 to 2. I doubled it. So you get the idea of common ratio. Common ratio. So similar polygons have the same shape. And here you can draw pretty much anything you want. What I'm going to do is I'm going to draw triangles because we're going to be comparing triangles, and hopefully my triangles come out a little bit better. I'm not sure why my draw board loves to do this to me. So I'm going to draw one triangle here, and then I'm going to draw a smaller version of that triangle, and we're going to assume that these guys are the same shape, which means this angle and this angle are the same. This angle and this angle are the same. And this angle and this angle are the same. So, if two polygons are similar, two things are true. The corresponding angles are, and here's that big word, congruent. So we talked about how the corresponding angles, the angles that match up, and I color-coded them up here for you, that one and that one, that one and that one, that one and that one, are the same. The corresponding sides are, and here's a big word, and we did this in the previous lesson, proportional. You've seen that word proportion before. Remember, proportion is two equal ratios. Two equal ratios, and we're going to use that for the sides. So let's advance down here. Use the figures below to answer the questions that follow. Now, I want to highlight this symbol. That symbol means similar. Anytime you see that little squiggly, that means similar. That means that these two triangles are the same shape. It means they are not necessarily the same size. So down here, it's going to ask you to match things up. What would angle A, knowing that these two are similar because I told you they were with that symbol, what would angle A match up with? Well, it would be congruent to angle X. And again, if you want to draw your little arc like that for your angle symbol, you can. Let's do all the angles first. What would angle B match up to? Well, angle B has to be congruent to angle Y. And again, and that's kind of an ugly Y there. Let's do better here. There we go. And let's do the last angle. Angle C would have to be congruent to angle Z. Again, these are all necessary if these are to be similar. The angles have to be the same. Well, since we know they're similar, I'm going to now match up the sides. And you match these things up, guys, just like you did with congruent triangles. It's just now, while the angles are the same still, just like they were when they were congruent, the sides are now different. So AB, or let's look at BC. BC, and I'm trying to do this. Oh, no. Okay, I can fix this. Hold on one moment. We can always fix things. There we go. Okay. So BC is going to be proportional to YZ. Do you see how that has a colon there? This does not mean equals, guys. They are not equal. Similar is not equal. It has to do with shape. So BC is the same shape, which means when we do proportions and factors and ratios, they'll match up together. It's the same shape as YZ. So my next one, AB, is going to be proportional, again, proportional with XY. Okay, those two are going to be proportional. And my last one, CA or AC, has to be proportional with XZ. So that's how you match up the sides with similarity and proportionality. Again, proportion, we talked about ratio and proportion in the previous lesson. You needed that because now we're going to be comparing figures. So let's scroll down. Example 2 says, if LMN, triangle LMN, is similar to triangle RST, what must be true? Well, we just did the angles above. So we have to match up our angles and our sides. So let's look at our angles. L has to be congruent to R. Now remember, angles are congruent. So angle L has to be congruent to angle R. So I'm going to mark them as such. I also know that angle M must be congruent to angle S. So M has to be congruent to S. And then, by the same token, angle N must be congruent to angle T. So I've just matched up the congruent angles, because remember, the angles are congruent, but the sides are not. Remember, the sides are not congruent. They are proportional. They have matching ratios. So I'm going to put proportional there. So LM and RS have to be proportional. So LM matches up with RS. And again, they are not equal, which is why I'm not marking them equal. MN goes with ST. So MN is proportional with ST. And then we have LN, if you look up here, LN and RT, which are proportional. LN, whoops, let me reset, is proportional to RT. So that is how you pick out the congruent angles and the proportional size. Sorry guys, I'm a little all over the place. I am still battling COVID, so I'm having a little bit of fun with that. All right, so that gives you an idea on how to match up the proportional pieces. Just to add a note, when we talk about similarity and congruence, we've already talked about the word included. And it says an angle is said to be included between two sides, and a side is said to be included in between two angles. Now, we talked about included with congruent triangles. So let's re-examine the idea of included to finish up this video. Included is a concept. Whenever you think about somebody being included, included means involved, right? If I include you in my group, that means you're a part of the group, right? You're in the group. You're physically a part of the group. So included has to do with being a part of something and in being in between. So you're going to see this word between. Name the angle that is included between AM and MC. So if I do AM and MC, what angle is included in between them? Well, that is angle M. Okay. Now let's move to the next one. Name the side that is included between angle A and angle M. So now I'm looking at angle A and angle M and wanting to know what side is between them, and that would be side AM. So you're looking for the pieces that are included between. In the last one, name the side that is included between angle A. Okay, hang on a second. Angle A and angle C. So angle A is here, angle C is here. So the side that's between them is AC. So hopefully that helps you with the location of the pieces in similarity and how to actually match up the sides and the angles. And remember, angles are congruent, and I'm going to write this again. Angles are congruent, but sides are not necessarily congruent. They are proportional. And we will discuss proportional with the sides in the next video.